Hi, 6th grade. This is Mrs. Conant, and this is our very first math video. We are going to start with Chapter 4, Fraction Theory. Our first lesson is going to be on greatest common factor, and I want to remind you that in order to be prepared for this video, you need to make sure you have your math journal and a pencil. You're going to be taking notes in your math journal. You're also going to be doing your 3 practice problems at the end of the video in your journal. And all of that will be due tomorrow morning. So let's get started.
The first thing we're going to do is we're going to review some math terms. The first term we're going to talk about is the term factor. Now, a factor is one of the numbers multiplied to find a product. So let's take a look at an example. Here is our multiplication equation. 3 times 2 equals 6. Now, in that equation, we see that both 3 and 2 are factors. And if we multiply them together, we get a product of 6. Just as a reminder, the product is the answer to a multiplication equation. Now the next term that we're going to talk about is prime number. A prime number is a number that only has 2 factors, itself and the number 1. An example of a prime number is the number 3. Now 3 is a prime number because 3's only factors are itself and the number 1. We can see that here in these equations. Only 3 times 1 or 1 times 3 can give us a product of 3. So 3 is a prime number. Our final math term that we're going to talk about today is composite number. Now, a composite number is a number that has factors in addition to itself and 1. Basically, that means that it has more factors than itself and the number 1, which is the only factor that a prime number has. So an example of a composite number is the number 9. Now 9 is a composite number because not only do we see that 1 times 9 and 9 times 1 give us a product of 9, but we also see that 3 times 3 also gives us a product of 9. So 9 is a composite number. Now we're going to be taking a look at some factors. Since our lesson today is specifically dealing with greatest common factor, we're going to first begin with common factors of numbers. So let's first take a look at this list of numbers, and we're going to look at all of the factors. Now let's first start with the number 12. We see right here that 12 has factors of 1, 2, 3, 4, 6, and 12. Now these are all factors of the number 12, and we can take different pairs of these factors, multiply them together and get a product of 12. We can multiply 3 times 4 and get 12. We can multiply 2 times 6 and get 12. And we can multiply 1 times 12 and get 12. Let's take a look at some of the other factors of the rest of the numbers in this list. So you can see that there's a variety of both prime and composite numbers on this screen. We see the number 3, which is a prime number because its only factors are 1 and itself. And we see the number 10, which is a composite number because its factors are both 1 and itself and also 2 and 5. 2 times 5 give us a product of 10. Now we're going to move on to common factor. Now, in order to find the common factors, we first have to list out the factors of each number. And so we're going to use 8 and 12 as an example. We first see the factors of 8 as 1, 2, 4, and 8. And we see the factors of 12 as 1, 2, 3, 4, 6, and 12. So we are going to look for factors that these two numbers have in common. And we see that the factors that they have in common are 1, 2, and 4. Now the greatest common factor is the greatest or largest number that these two numbers have in common. And in this case, the greatest common factor is the number 4. Now, I want to point out that the greatest common factor, or the GCF, as we like to abbreviate it, of two numbers is never going to be more than the value of the lesser number. Let me explain what that means. The greatest common factor of 8 and 12 is the number 4, and that number is less than the lesser of these two numbers. Now, the lesser of these two numbers is the number 8, and the greatest common factor is 4, which is less than an 8, and it always needs to be that way. If for some reason you're working out a problem and your greatest common factor is larger than the lesser of these two numbers, then you know that there's been a mistake in your calculations and you need to go back and check your work. Let's take a look at these three numbers, 6, 9, and 12. And let's go ahead and first find their common factors. We can see that their common factors are 1 and 3. So now we're going to determine the greatest common factor, which we look for the largest of the factors, and we see in this case it's the number 3. Now we're going to take a look at another way to diagram greatest common factors. And we're going to do that by looking at a Venn diagram. Now, a Venn diagram pictures the relationship between sets. Okay, so we are looking at sets of numbers, and this Venn diagram is going to help us to have a picture of the relationship between these sets. Now, on a Venn diagram, common information, so information that the sets have in common, is written in the intersecting part of the circles. So that's this part right in the middle. And information that is different between the sets is written in the non-intersecting parts of each circle. So that would be right here and right here. So we're first going to take a look at the factors of 18, which we have right here. We're also going to be looking at the factors of 24, which we have written right here. Now what we're going to do is we are going to write the common factors of 18 and 24 in this intersecting part of the Venn diagram. So first we're going to take a look at our list and we're going to find our common factors. And we can see that those common factors are 1, 2, 3, and 6. And so we're going to write those numbers in the intersecting part of our Venn diagram. Now, the factors that we have left over that are not in common, we're going to write them in the non-intersecting parts of the Venn diagram. So for the factors of 18, we're going to write 9 and 18. And for the factors of 24, we're going to write 4, 8, 12, and 24. So we see that right here in our intersecting part of the Venn diagram, we have common factors of 1, 2, 3, and 6. Now, as we look at these common factors, remember we're also going to be looking for the greatest common factor. And so of these four factors, the largest or greatest number is the number 6. And so 6 is the greatest common factor of 18 and 24. Let's practice again with the numbers 15 and 25. First, we're going to write the common factors of 1 and 5 in the intersecting part of our Venn diagram. Then we're going to write the differing factors of 15, which are 3 and 15, on the non-intersecting part of the Venn diagram, and the one differing factor of 25 on this non-intersecting part of the Venn diagram. Again, let's look at our common factors, and we're going to look for the greatest common factor, which in this case is the number 5. Now let's take a look at greatest common factor using prime factorization. Now, prime factorization is another way to find the greatest common factor. You probably remember factor trees from 5th grade. Now, do you remember factor trees are where you write factor pairs underneath a composite factor and you keep breaking them down until all of the factors are prime. Now, just in case you don't, let's go ahead and take a look and refresh our memory. So we're going to take a look at the composite factors of 18 and 24. And we're going to begin by thinking of two factors that we can multiply together to get the number 18. Now we're going to use 9 and 2 because 9, the factor 9 times the factor of 2 gives us 18. Now, this is not the only set of factors that we could have used. We could have used 6 and 3. Now, whether you use 9 and 2 or 6 and 3, either way, your prime factorization is going to be the same. So you have options for what you can use. But we're going to use 9 and 2 to begin. And we're first going to take a look at the number 9. And we're going to ask ourselves, is 9 a prime number? If it is not a prime number, then we need to continue to break it down. And so 9 is not a prime number. We need to break it down to 3 times 3. So let's check 3, the factor of 3 times the factor of 3 gives us 9. Now, is 3 a prime number? Are its only factors 1 and itself? The answer is yes. So we're now complete down here at the bottom on this side. Let's go over to the other side of our factor tree. We have the number 2. Now, is 2 a prime number? Yes, 2 is a prime number. Its only factors are 1 and itself. So we're going to bring that 2 down, and now our factor tree for 18 is complete. All of our factors are now in their prime form. Let's move over to number 24. We're going to start with the two factors of 6 and 4. Because 6 times 4 gives us 24. So let's ask ourselves, is 6 in its prime form? No, it is not. We're going to break that down to 2 times 3. 2 is now in its prime form, and 2 is in its prime form, and 3 is in its prime form. So this side of our factor tree is complete. Let's go over to the number 4. Is 4 a prime number? No, it's not. It is a composite number. So we're going to break 4 down to 2 times 2. Now, 2, we already know that 2 is a prime number, so we know that our factor tree is now complete. The next step that we're going to do in finding our greatest common factor using prime factorization is we're going to list out the factors of each number in this way. We're going to put our composite factor that we began with equals, and then we're going to write all of the factors that in their prime form. So we're going to write the smallest number first, which is 2, times 3 times 3. So 18 equals 2 times 3 times 3. Let's check to see if that's correct. 2 times 3 gives us 6, and 6 times 3 gives us a product of 18. So that is correct. Now let's look at 24. We're going to start with our composite factor that we began with, the number 24, and we're going to write out all of its prime factors. So we start with the smallest numbers, which are 2. 2 times 2 times 2 times 3. Let's check our multiplication. 2 times 2 is 4. 4 times 2 is 8. And 8 times 3 gives us 24. The next step is we are going to take a look at all of our prime factors here, and we are going to find the common prime factor that we have. Our first common prime factor is the number 2. We also see that we also have a common prime factor of 3. So we're going to take our two common prime factors, 2 and 3. We're going to multiply them by each other. We will get a product of 6, and 6 is our greatest common factor of 18 and 24. Let's take a look at another way of looking.
I want to give you a chance to practice prime factorization. So why don't you go ahead and take a minute to figure out the prime factorization of 28 and 44. Press pause on your video right now and complete the factor trees and finding the greatest common factor of 28 and 44. When you're finished, hit play again and we'll go through the prime factorization and greatest common factor together. Okay, let's take a look at this problem together. So we see that with 28, we first began by taking the factors of 4 and 7. We multiply those two together and it gives us 28. We ask ourselves the question, is 4 a prime number? 4 is not a prime number, so we need to break that down further into 2 times 2. And we already know from our previous problem that 2 is a prime number, so we are now complete on this side. Then we move up to 7. 7 is a prime number, so all we have to do is bring that down, and that completes this factor tree. 2 times 2 times 7 gives us a product of 28, and 2, 2, and 7 are all prime numbers. Let's move over to 44. So with 44, we needed to determine two factors that we were going to multiply together, and we have 4 and 11. So we multiply 4 times 11, and that gives us 44. 4 is not a prime factor, so we're going to break that down to 2 times 2. And then we are going to look up at 11. That is a prime factor, so we're just going to move that down, and this factor tree is now complete. Our next step is to write out our prime factors in this form. So we start with our number 28 equals 2 times 2 times 7. And then we have 44 equals 2 times 2 times 11. Then we look for the greatest common, or the common factors, We look for the common factors, which in these two equations, they are 2 and 2. So we take those two common factors, we multiply them together, and we get a product of 4, and 4 is our greatest common factor of 28 and 44. You've now come to the end of your very first video. I hope that you have been able to take good notes. We are going to take some time tomorrow in class to talk about our first video, and we're also going to discuss further this lesson. So if you have any specific questions that have come up as you've watched this video, make sure you jot them down in your math journal, and we will talk about them tomorrow. Here is your assignment for tonight. First, you need to make sure you have your notes from watching this video in your math journal. And then I would also like for you to complete problems 1 through 3 on page 76. Those are 3 practice problems that will help me see if you got a good introduction to our lesson on greatest common factor. Now, just as a reminder, your notes and your practice problems must both be completed in your math journal. Okay, we're going to keep all of that information together in one place. All right, well, just so that you don't think that math videos are boring, I'm going to end this with a math joke for you. So here's your math joke. Why was the math book sad? Answer, because it had too many problems. All right, I'll see you guys tomorrow.